Assignment 7-2, let's get to it. Question number 1, you're given a sequence, and all you're asked to do without a calculator, write the first 5 terms of this sequence. So plug in 1, and it's 2 over 1. Plug in 2, and then 2 squared is 4. 2 factorial means 2 times 1, so it's 4 divided by 2. Plug in 3, 2 to the 3 is 8. 3 factorial, if I will put it right here, 3 factorial is 3 times 2 times 1. You don't have to simplify it. 4, 2 to the 4. 4 times 3 times 2 times 1. And then 5. 2 to the 5 is 32. 5 times 4 times 3 times 2 times 1. And you have it. I think. Yeah. Number 2. Plug in, those aren't very fancy. Plug in 1, plug in 2, plug in 3, plug in 4, it's a positive, and then 5, was that 243? Yeah. Number 3. Knowing your unit circle, plug in 0, plug in 1, and it's 0. Plug in 2, and it's pi. And we're just going to go around the circle. And there they are. Number 4, write the first 5 terms again. So this is recursive. So the first term is 2, and then we use that. 2 plus 2 is 4 times 3. Then 12 plus 2, 14 times 3. And then 42 plus 2 is 44 times 3. And then 132 plus 2 is 134 times 3. And you have your answer. Number 5. Alright, so we'll start with 0. So sine pi over 2 is 1, and 1 times pi over 2 is pi over 2. Now we plug in pi over 2, and pi over 2 plus pi over 2 is pi. That's 0. Plug in 0, so it's sine pi over 2. That's 1 times pi over 2. I see a pattern. And there you go. Is that too many? Oh, it says A1 is 0, so that's actually the pattern right there. And it would stop right there. Number 6. This is called an arithmetic series. It's increasing by 3, so the formula would be 3n minus 1 plus the first term. Number 7, this is called geometric. You're multiplying by 2. So the first term, the base is what you're multiplying, and then the exponent. Number 8, also geometric. You're multiplying by negative 1/2 every time. So the first term is 5, and then the base is negative 1/2 to the exponent n minus 1. Number 9, do you know what a factorial is? Can you simplify a factorial? So take the larger factorial and count down. So 10 times 9 times 8, and then stop when you get to 7, and then cross out, and then there's your answer. What answer is that? It's 1 over 720. Is that right? Number 10. In number 10, you have 2n plus 1 and then 2n minus 1. So take the larger one, which is 2n plus 1. Subtract 1, that's just 2n. Subtract 1, that's 2n minus 1. Stop there at 2n minus 1. They cross out, and you have your answer. Number 11. Find the limit of each and whether it diverges or not. So to infinity, you're asked to ultimately find the limit as n approaches infinity of this sequence. So what's the end behavior? So power term over power term, they divide out to 1/3. Number 12, I'm just going to write as a limit right away. The limit as n approaches infinity. So the right end behavior, this is the power term, the 2 would go in front. And a logarithm is, the 3n is more powerful. So you can take the derivative because it is indeterminate. And you end up with 2 and then 1 over n for the logarithm. And then the derivative of 3n is 3. So you can see the bottom is more powerful than the top. So the limit converges to 0. Number 13. This one diverges. It goes back and forth, back and forth. Cosine oscillates. Oh, no, it doesn't. So 1 over n. So if the bottom is more powerful, that converges to 0. And the value of cosine 0 is 1. Well, there you go. I wasn't thinking straight. 14. So the limit of this as n approaches infinity this is n squared divided by n squared. But this alternates, positive, negative, positive, negative. So this diverges, and it does not converge to an answer. Number 15. I'm going to write it as a limit right away. So the right n behavior is 3n, and the square root of n squared is n, so divide it, and the answer is 3. So when they talk about whether it converges to an answer, they're only talking about the right n behavior. So the left n behavior is actually negative 3. But we're not talking about that, just talking about the right n behavior. So again, here's an example that's going to oscillate over. So because it is bounded over unbounded, this thing diverges. So this numerator goes positive, negative forever. So it never converges to a number. 17. Here, the bottom is more powerful than the top. So this is 0. And 0 times anything, the answer is 0. Number 18. So, I meant to write this as a limit right away, but I didn't. So I'm going to count down and simplify it. N plus 1, and then n factorial. So notice the n factorials divide out, but n plus 1 for infinity. Oops. So this divides out, but this is still unbounded. Number 19. So in other words, this diverges. It doesn't converge to an answer. Instead, it goes to infinity. Number 19. So we have negative 1, 1/4, negative 1/9, and 1/16. So then we're thinking, what is a rule that I can use? These can be kind of tricky. So I know that it oscillates negative, positive, negative, positive. That will allow it go negative, positive, negative, positive. And when I look at the denominators, 1, 4, 9, 16, those are perfect squares. So that would be a situation what it would look like. I know it's tricky. 3 over 2, 4 over 3, 5 over 4, 6 over 5. What's a pattern that we could use here? So if I look here, if I plug in 1, I'd have to add 2. If I plug in 1, I'd have to add 1. So as I plug in and go up, it's n plus 2 over n plus 1. So it matches. 21. So look at the numerator. 2, 4, 8, 16. That's an exponential. So that's 2 to the 1, 2 squared, 2 cubed, 2 to the 4. Look at the bottom, 1, 3, 7, 15. Notice how it's always 1 less, 1 less, 1 less, 1 less. So it's the same, but then you subtract 1. And now it's a rule that you could use. 22. See if we can see this pattern. So I see what the numerator is. So the numerator is 3. How about 1, 2, 6, 24? What's happening there? And so this is actually a factorial. So 1, and then 2 times 1, and then 1 times 2 times 3, and so on. These, 1, 2, 6, 24, 120, those are factorial in terms of what's happening. 1 factorial, 2 factorial, 3 factorial, 4 factorial, and so on. 23. This one has a variable expression in it. So if I have x to the exponent n minus 1, when I plug in 1, 1 take away 1 is 0, and x to the 0 is 1. If I plug in 2, 2 take away 1, that's x. If I plug in 3, and so on. Look at the denominator. I think we're looking at that. So that's going to be n factorial. Those are 2, 6, 24, 120, and so on. 24. Negative 1, 1, 3, 5. I'm counting by 2s. So 2, so every time you add 2, and then the first term is negative 1. Or you could write down, you could expand it if you wanted to. 25. 1 over 1, 4 over 3, 9 over 9, 16 over 27. So if I look at the denominator, I see cubes. So that's going to be n cubed. So when I plug in 1, it is cubed, but it's 3 to the n minus 1. So if I plugged in 1, it's 0, and 3 to the 0 is 1. And if I plug in 2 or 3 and so on, but it is that 3 that you multiply every time, so it's geometric. This one, 1, 4, 9, 16, that's squared. So it's going to be that. Where you multiply and you're squaring. No, you're squaring it. So n squared. Because 1 squared, 2 squared, 3 squared, 4 squared. So it's n squared over 3n to the n minus 1. All right, 26. And this is a question of whether it's monotonic or bounded. So because it's negative 1 to the n, as you plug in 1, 2, 3, it's going to go positive, negative, positive, negative, positive, negative. Because of that, it is not monotonic. But as you plug in large numbers for n, 1 over n squared is going to 0. And 0 times anything is 0. So it is bounded to 0. It's just not monotonic. So when you think of what the limit value is, does it converge to an answer? Then it's bounded. This monotonic, it has to only increase or only decrease. So when I look at 27, because it's cosine, it's going to go positive, negative, positive, negative. So it is not monotonic. And then when I look here, same thing, because it oscillates, it doesn't converge to an answer. I also have n cubed over n squared. So this is also not bounded. So there is no right end behavior that it gets bounded to. 28. So as we plug in positive 1 and more, this is monotonic. It gets smaller and smaller and smaller, and this does converge to an answer. So eventually, it's going to converge to 0 or what the answer is in this. So it's because it goes 1/2 and it gets closer and closer and closer. The right end behavior is 0. That means this is bounded. And if you want to think about it, the largest number it could be when you plug in positive 1 is 1/2, and this is going to go to 0. So it's bounded between 1/2 and 0. 29. Here's an example where the base is bigger than 1. So this is monotonic. It's just increasing. It doesn't go back and forth. But this is unbounded because it's going to infinity. It's not converging to an answer because the base is larger than 1. Turn the page. All right, so those are the lesson questions, right? Now these are review questions. They're so important to do. This is called an improper integral because the upper bound is infinity. So we're going to let this be we can use either letter. When you integrate e to the negative x, the hook is negative, so it needs to be negative in front. So it's negative e to the negative x. And again, I need to write it as a limit. Don't lose that limit notation. Sometimes I lose that limit notation. Not yet. And then we plug in so first I'm going to plug in b, and I'm going to write it calculus friendly. And when you subtract a negative, plug in 0. And then simplify it. So this is going to be 1. And then as this approaches infinity, the bottom is more powerful than the top. This is going to be 0. So it's actually 0 plus 1, which equals 1. Number 31. This is an improper integral because when you plug in 6, it's undefined. So we're going to write it as the limit as a approaches 6. Why not? Then I'm going to write this make sure you keep the limit notation. I'm going to write this in calculus friendly. The hook should be -1. So what it was over what it became, this is going to be -4. So we start with -4. We add 1 to the exponent, and then divide or times the reciprocal from 0 to a. I'll continue up here. Still the limit. That's -8. And then I'm going to plug in 0. Subtract a negative. It's 8. Plug in 9 first. And then 9. Plug in a first. And 6 take away a. And then plug in 0. So now when I look at this and I plug in 6, I can actually get an answer. So 6 take away 6 is 0. So this is 0. So what I'm left with is 8 times the square root of 6, or 8 times 6 to the half. 32. The derivative of the bottom, so first of all, let's write this as a limit. This is a logarithm, because the derivative of the bottom matches the top. Keep that limit notation. We're going to plug in b first. Subtract, plug in 0, and then we're going to look to see what happens here. So a logarithm goes to infinity. So this is going to diverge. This does not converge to a number. Ln 1 plus 1, that'd be ln 2, but this one diverges. It continues to go to infinity. So it does not converge to an answer. Number 33. Find g at x. The second derivative is 2x subtract 3. I don't know why I have this here. So the first derivative is the integration of that. And then it says g prime at 0 equals -5. So make it equal to -5. When you plug in 0, c is that. So the derivative is x squared subtract 3x subtract 5. Integrate again. Add 1 to the exponent and divide. Make sure it's plus c at the end. This time, they give you -1 and 2. So plug in -1. And then we're going to solve it. So we're going to get common denominators and then solve for c. $30 take away 11. What is that, 19? This could be over 6 too. So when you subtract, I get -7 over 6. Let's see if that's true. Yep. And then plug that in. So make sure we write it again. So y equals, or g at x equals, x cubed over 3 minus 3x squared over 2 minus 5x, and then c is equal to -7 over 6. All right, 34. In number 34, you're given the acceleration and the initial velocity and the initial position. So, integrate. So that's going to be add an exponent and divide. That's 3t squared minus 4t. Plug in this. So when you plug in 0, the answer is going to be 5. Find the velocity at 2. So if you plug in 2, $12, take away 8, 4 plus 5, that's 9. Find a position. So the position equation for the object would be the integration of this. And again, the initial position is -2. So C, when you plug in 0, the answer is going to be -2. And then what's the position at 2? So 8 take away 8, 10 take away 2, so the position's 8. 35. A ball is dropped, and use the equation S at t equals -16t squared plus the initial velocity plus the initial position. So the initial position is 160 feet above the river. How long will it take the ball to hit the water? So if you take the position, it will hit the water when the position is equal to 0. You can take the derivative of that. So because you're dropping the ball, the initial velocity is 0 because you're just dropping the ball. And then you make it equal to 0 and solve it. So I'm going to add 16t squared, make it equal to 160, and then I'm going to divide and see what's up. All right. Divide by 16 and then square root. So the answer is, in root 10, it will hit the ground. All right, 36. Y equals x to the 2/3 parallel to this. So I want to solve for y. I'm going to subtract 5 and add 6y. I'm going to divide by 6. And this is what I'm interested in. So that gives me the slope. So I know the slope is 1/3. So I'm going to take the derivative, because the word is parallel. I'm going to take the derivative, and I'm going to make it equal to the slope. So I'm going to write this calculus friendly. I'm going to make this is 6. I'm going to cross multiply here just for fun. Divide by 3. Cube it. And I get x equaling 8. If x is 8, plug it in. The cube root of 8 is 2, and 2 squared is 4. And now I have everything I need. So y equals 1/3 x minus 8 plus 4. Done. 37. y equals ax cubed plus bx squared plus cx plus d. It has a relative maximum point at 0, 2, and it has a point of inflection at -1, -2. All right. So first of all, I'm going to plug in the point 0, 2. So if I plug in the point 0 for x and 2 for y, d, we already know, is equal to 2. Next, I'm going to plug in the second point. That's -2. -1 makes that -a, positive b, -x. Subtract 2 and you have an equation. Oops. So if I plug in -1, it'd be -c. That's what it should say. And then I subtracted 2, so now I have an equation. I'm going to take the derivative of this. And I know that there's a maximum at 0. So the derivative I'm going to make equal to 0. And if I plug in 0 for x, then c is equal to 0. So now I have -4, -a plus b, because c is 0, so we have two values left. I'm going to take the derivative again. That's 6ax plus 2b. Again, the point of inflection, the derivative will equal 0 when the x value is -1. So now I have 0 equals -6a plus 2b. I'm going to multiply by -2. And then I'm going to eliminate the b by adding. So a, when I divide, I get a equaling -1/2. Oh, sorry, when you divide, 8 divided by -4, I'm sorry, is -2. So now I get a is equal to -2. It doesn't matter which one you pick. Let's say you pick here. Pick -2 in here. A negative times a negative is +2. Subtract it, so b is equal to -6. And then put it all together. So y equals a, -2x cubed, b, -6x squared, c, that's 0, and then d plus 2. And there's your equation. 38. It says, list the domain. So x cannot equal positive or -1. The vertical asymptotes, I'm going to factor the denominator out. Nothing simplifies, so they both are vertical asymptotes. Holes, no holes. X-intercept, the numerator, so 0, 0. That's also the y-intercept. And the end behavior. So the right end behavior and the left end divide the power terms. So both the right and the left is equal to 1. So y equals 1 is the horizontal asymptote. And then sketch this. So at +1, at -1, and at y equals 1, those are the asymptotes. We have an intercept here, and then we draw it from there. So I know the behavior at the vertical asymptotes, and I know it's an odd vertical asymptote, and the behavior odd, and the behavior, and you've drawn it. 39. Average value is an integration question. I'm going to write it calculus friendly from 1 to -2 to 1. And then when you subtract it, that number is 3. That's the difference. So we have a 1/3. The hook is negative, so it's going to be negative in front. And then I'm going to add 1 to the exponent instead of dividing times the reciprocal. And that's from -2 to 1. So I have -2/3, plug in 1, subtract a -2/3, plug in -2, and you have your answer. That's a good enough answer for me. Number 40. In number 40, sketch this region. X equals y squared minus y, and x equals 0. So I'm going to factor it. This is a sideways parabola. And the y-intercepts are at 0 and +1. And then we're going to draw a sideways parabola from there. And then x equals 0, and then this. And then find the area. This is going to be right. So first of all, we're going to integrate. And the bounds go from 0 to 1. And then it's right, subtract left. And then I answer it. So we are going to add 1 to the exponent and divide. A negative times a negative, we're going to add 1 to the exponent and divide, and that goes from 0 to 1. And then you plug in 1. And then when you plug in 0, the answer is 0. Do you know what the answer is here? It's actually 2, -2 plus 3. It's 1/6. -2 plus 3 is 1/6. All right, number 41. F at x equals x cubed. Find the value of c so that from -2 to 0, so this is average rate of change, A rock. So I'm going to plug in -2, plug in 0, subtract -2, over 0, subtract -2. So if I plug this in, that's -8, which makes it +8 over 2, which is 4. And then when I take the derivative of this, it's 3x squared. And then take the derivative equal to 4. So x squared equals 4/3. When you square root, it's going to be the negative answer because of the domain restriction. So when you square root this, it could be positive or negative, but it's negative because negative root 4/3 is in the correct restriction. Done. 42. Y equals 3 cosine t minus 2. Take the derivative. The derivative of cosine is negative sine. I think that's it. 43. Just some good basic practice. You should press pause and try. The derivative of x is 1. The derivative of sine is cosine, and it has a hook of 2. 44. I'm going to write this as cosine x squared plus 1 all squared, so you see what we're going to do. So the derivative is going to be the power rule, 2 in front, rewrite everything inside. Subtract 1 to the exponent. Then the hook, the derivative of this is negative sine. the derivative of this is 2x. So it has a double hook. Number 45. So again, you should press pause and try it. Go ahead. The derivative of tangent is secant squared, and then the hook, and then minus 2 theta. 46. Press pause. Try to do the derivative. It's a fraction. What you see, the derivative of cotangent is negative cosecant squared. That's perfect. 47. The derivative of the cosecant is cosecant negative cosecant cotangent with a hook minus secant, which is secant tangent with a hook. Number 48. The derivative of the bottom doesn't match the top. So what direction can we go here? This is going to be the quotient rule. So that's the bottom times the derivative of the top. Subtract the top times the derivative of the bottom, and then the bottom squared. Just be a rule follower and it's not so bad. Last one, 49. I ran out of space. I can do it right here. 49, so I don't waste another piece of paper. G of t equals t cubed. I'm going to write this as tangent t cubed all to the exponent 3. So this is going to be the product rule. That's the first times the derivative of the second. So this is the power rule. 3, copy. Subtract 1 to the exponent. The derivative of tangent is secant squared. And then the derivative of t cubed is 3t squared. So that's the first times the derivative of the second plus the second. Just copy it. Times the derivative of the first, and it's done. That's it. All right, Mr. G Math over and out. I'm super proud of you that you got to the end of this. Keep doing your best. Till next time.